Hi, good afternoon, everybody. This is Csaba from Aerospike. I'm part of the technical marketing team. And today I would like to cover a very interesting topic. It's basically streaming for real-time decisioning using Kafka, Spark, and of course, Aerospike. And as part of this short presentation, I will also have a demo. So again, thanks for listening in for this session. Before I jump into the actual description of the demo and the use cases, let me give you a quick introduction to Aerospike. Aerospike is a key value store, and please remember that because later on during the demo, I'm going to refer to a certain structure we have. And this key value store is ideal for a streaming architecture. The reason for that is because we have very, very high ingestion rates when we are talking about millions or hundreds of millions of records per second, which can actually be entered into the database. To achieve that amazing ingestion rate and, of course, the high scalability, Aerospike actually has a patented hybrid memory architecture. There are multiple components in this architecture I would like to cover. So first of all, the storage layer, it's basically flash, and there is a proprietary way or algorithm, if you will, how we actually write data onto SSDs. By utilizing these patented algorithms, we actually can write much faster and much more efficiently on SSDs, which ultimately increases, obviously, the insertion rate and also increases the scalability. The data can be stored in different ways. Again, please keep in mind that this is a key value store. The indexes can be stored in DRAM, and the data then can be stored on SSDs. And ultimately, this enforces the capability for us to provide a predictable performance at any scale. I think starting from a couple of years ago, we also support Intel's PMEM memory. And in this case, actually, we can store, let's say, the indexes in PMEM and data still on SSDs. Or later on, we also added an option to store both indexes and the data on the PMEM. So ultimately, this is to accelerate the performance, the speed of the injection and transactions in the database. The architecture is multi-threaded, massively parallel, which allows us to scale up, meaning we can utilize and scale up the actual node itself. And we can also scale out, which means actually we can add additional nodes very efficiently. We also have self-healing clusters, which result in superior uptime, availability, and reliability. So exactly, for example, one node goes down, other clusters will take over, no single point of failure. There's one more very important point I would like to make here. We also have a single hop to data, meaning Aerospike uses clients, and these clients can be C or Java or Python or Go or other languages. And these clients actually understand where the data resides within the cluster, so that they can actually access the data in a single hop. Again, ultimately, that increases the performance for both reads and ultimately I can also insert the data faster. Because of this very extensible and very robust architecture, which can handle enormous ingestion rates, we also have, it's ideal for streaming architecture, but we also have very large customers who are using this technology for various purposes in different industries. But as you can imagine, for example, in ad tech, e-commerce, financial services, ingestion rates can be very, very high. So for example, I think in the presentation earlier this week, we covered Schwab and DBS Bank for Kafka use cases. So in both cases, actually, Aerospike utilizes Kafka, utilizing the Aerospike Connect for Kafka for both cases. But again, Aerospike is not limited to FinServ. It also covers new tech, media, telco, and gaming use cases. And in all of these use cases, we can assume there will be lots of data collected in a very fast time interval, which we have to ingest into the database. So before I jump into the Aerospike Connect for Kafka, which is our connector. Let me just briefly explain. We actually have a product line, the Aerospike product line, Aerospike Connect product line, which actually allows integration of Aerospike technology with the enterprise. What that means is that we have Connect for Kafka, Connect for Spark streaming, obviously, and also to JMS. But ultimately, our goal with this product line was to establish Aerospike as a data source, or ultimately the data, the system of record or edge database, meaning I can integrate Aerospike with any data source in the enterprise and utilize it either for, as an edge database or as a system of record. So in this case, let's talk about the Aerospike Connect for Kafka. And actually, Aerospike can receive data from Kafka clusters, Kafka data sources. So let's assume there is an IoT device or different edge devices. The data can be pumped into Aerospike from these IoT or edge devices. What happens, there is actually a function in Aerospike called change notification. And people who are familiar with the relational terms, it's similar to change data capture, which we used in the past. So ultimately what happens is all the transactions are being actually as part of the chain notification can be pushed into an outbound connector, which is a Kafka producer. And then from the Kafka producer, it goes to the Kafka cluster, and ultimately it can be distributed into different applications downstream. So again, this is kind of the outbound mode for Aerospike Connect for Kafka when we're actually pushing data out of Aerospike. If you look at the mapping between the Aerospike terminologies, remember I mentioned Aerospike is a key value store. So we have namespace, we have set, record, and bins, which is actually has equivalents or similar topics, or I would say in our DBMS world, database, table, or column. But ultimately, what's the most important on the slide is actually these are mapping to the Kafka topics, the namespace and set. The records are mapping to the Kafka event or message, and the bins, which are kind of like columns in the database in the relational world, are mapping into topics which based on the bin value. So ultimately, this allows us to map the Aerospike data sets, if you will, into Kafka. So that was the outbound connector. We also have, as I mentioned, an inbound connector, in which case the data is coming in from various applications. It actually goes to the Kafka cluster first. And from the Kafka cluster, it's actually goes to Aerospike Connect, which is actually a sync connector in this case. And ultimately, the data is being pushed into the Aerospike database. The data formats which are supported are the mainstream ones, I would say, JSON, Avro, message pack, flat JSON. But Aerospike also supports complex data types, CDTs. So if the data is in a complex data type, we just have to specify within the configuration it's a CDT, and all the information will be automatically transferred. So we don't have to deal with complex configurations here. We just have to specify the CDT. Currently, the Kafka connector, again, which has both outbound and inbound functionality, is compatible with the open source Kafka and also with the Confluent platform. So let's take a look at the different use cases, which we actually presented, I think, earlier this week. And again, if you missed the presentation, either you can go back and review the presentation again, or you can go to the Aerospike website. We have a very, very extensive list of customers and use cases that you can look at how different companies are using the Aerospike technology. And some of them is also have obviously the Kafka connector too as being utilized. So obviously the IoT devices, when you have a large number of devices and you want to collect data, various data points from these devices, that will result lots of data potentially coming in at a very fast pace. So obviously for this, Aerospike, for streaming this data, Aerospike Connect is an ideal technology. The same way with personalization, when different customer attributes are being added on a very high pace, and we want to create a customer 360, again, Aerospike Connect can provide that functionality. There are some interesting cases for advanced analytics, and I think we covered kind of a use case for COVID discovery tool yesterday. But again, just going back to the typical enterprise environments, this technology can be used for mainframe offloading, high-frequency trading, and the high-frequency trading, I think that was the Schwab use case which was covered, and fraud detection. And as you can imagine, when there are different attributes of a transaction coming in very fast, and thousands of transactions or millions of transactions coming in a very fast pace, obviously we have to have the capability to ingest all of this data. So let me actually talk about the demo a little bit. I have to say that this is actually a very simplistic demo. It's running on one system, but we wanted to keep it simple since we wanted to explain all the steps in a very easy to understand way. So what we are doing here, as I mentioned earlier, we have different client technologies. In this case, we are using a Python client. And what the Python client does, actually, it pumps data into Aerospike database. In the database, we have a new namespace, a device, and we have a set, which is streaming byte set. And we have bins, 1, 2, 3, which actually collect the data, in this case, from the Python application. As I mentioned earlier, since the database is using the change notification function, utilizing Connect for Kafka, this data is being pumped into Kafka. And the configuration is very simple. It's basically a name-based routing. As I remember, I mentioned the how to map the different topics for the Aerospike technologies. And the topic is actually Aerospike. So what's going to happen is, based on change notification, data goes into Kafka. And then in the second part, from Kafka, we actually have direct, we actually using a direct data pump into Spark structured streaming API, and the data will be pumped into data frames. Of course, it doesn't happen immediately because Spark has a lazy execution, but ultimately when we run certain functions in Spark, then the data will be pulled into Spark. And of course, we actually wanted to just create a very simplistic function, which is a count function. What it does basically looks at the first bin, and it basically counts how many times a number occurred. Very simplistic, but obviously, as you know, Spark has much more sophisticated ML and AI capabilities. We just wanted to keep it very simple. And once we created the account, we actually create a new namespace and push this information back to Aerospike. It's going to be a new namespace called memory output. And again, what we'll have in this namespace is going to be the bin, which is a 1, and the count. So basically, for each number, we count how many times that number occurred. And again, for this, we are going to use the Aerospike Connect for Spark. So in this case, as I mentioned, we have very simplistic configuration. We have one partition, one replica. But obviously, in an enterprise environments, this can be a way much more complicated streaming pipeline. This is just a very simplistic example. What actually, of course, if you have a more sophisticated streaming pipeline, you can stream data into Spark, into data frames, and enable different AI, ML, and algorithms to run to detect or create some new data sets based on this information. This pipeline can be fault tolerant because all the technologies have fault tolerance built in. And the goal here is to handle millions or hundreds of millions events per second, obviously, at a low latency. So one reason actually we used Aerospike in this picture in the front end in section number 1 is because Aerospike can handle large amounts of, can ingest large amounts of data in a very fast pace. The reason for that is possible that let's say, for example, on the Spark side, or when you're using more sophisticated algorithms, it takes some time to calculate or transfer the data. So in order for these systems in section 2 to catch up with the incoming data volumes, Aerospike can handle that and ultimately let these systems behind it basically catch up with the calculation. So again, Aerospike can handle the ingestion, the high, the millions or tens of millions, or 100 millions records ingestion, but ultimately it can slow down the process behind it so the other systems can catch up. So let's look at the actual demo. So again, just as I mentioned earlier, we are using the Aerospike Python client. It's very simple. It's going to have a namespace, which is called device, a set, assuming right set. As you can see, we are going to push 100 million data points into the Aerospike database. And then from a client perspective, we are going to connect to the Aerospike client. And then what's going to happen is the data which will go into the database is going to have a key. As I mentioned, Aerospike is a key value store. It's going to have namespace set and basically the streaming numbers. So again, for the when the data actually gets in, it's going to have the bins populated. In the process, when the data goes into the database, we also involve the change notification. And in this case, again, it's basically the hashed version of the key. And also we have to push the numbers into the bin 1, 2, and 3. So ultimately, this is kind of the first part of the demo when we push the data into Aerospike, and from the Aerospike, we push data into Kafka. So let's look at how it works. So if you look at the configurations, again, it's start running Spike, we have the connect, and you also have Kafka, and Zookeeper is needed for Kafka. If you look at the left side, there's a little Python script, and ultimately this Python script pumps this 100 million records into the Aerospike database. So once actually I start running this, and then you can see the set, the namespace, and basically the key, and ultimately the bins. Once we actually launch this Python product, actually the lower part of the screen, this is basically the Kafka. We are using Kafka Cat, and this is basically the change notification infrastructure, where you can see that we have the set device, the hash, and the different numbers hitting the bins 1, 2, and 3. To make sure that we actually understand that the data is going into Aerospike, we can actually look at the, you can use the Aerospike AQL tool. And the AQL tool actually shows that we have the actual device, namespace, the set. And once we actually select the data from it, you will be able to see that the data is being populated into the bins. And that's, again, that's very simple, just to look at the incoming data. So again, we have proven that the data goes into the Aerospike, and based on that information, the change data notification actually pushes the data into Kafka. So in the next step, let's look at what happens with the data next. As I mentioned earlier, now we are going to push, since the data went into Kafka. Now from Kafka, we actually connected the API. Again, this is kind of a default configuration that will be coming from Kafka, the Bootstrap server, and it's going to be subscribed, and ultimately it's going to go into Aerospike. What you will see in the data frame, however, I have to again mention that the data is not written until this function, which is actually ultimately forces the data being earlier. We are going to just count the values in the bin number 1 and see how many times a specific number occurs. And once we have this count, we are going to then take this data and push it back into the Aerospike database. Again, it's going to be a new namespace. It's going to be called memory namespace, and it's going to again have the result go through the whole process. We push data into Aerospike, we push data into Kafka, and from Kafka we push it into Spark using the structured Spark streaming API, and ultimately for persistent purposes, we push back the data again into Aerospike database into a different namespace. So again, this is actually where you will be able to see. So this is actually, remember the first namespace, we had the device, and then the new namespace is called the memory. And you will be able to see, if I start running it, you will be able to see that the number in the memory namespace is continuously improving, increasing, if you will. So this way we actually can see that all the data is being ultimately pushed back into the Aerospike database. So if I want to actually go ahead and check what has been actually pushed back into the Aerospike database, again, I can go back to my AQL prompt. Again, AQL, as I mentioned earlier, it's kind of a SQL-like language which we can use to access data in Aerospike databases. And again, if I look at the data, what has been collected and pushed back into Aerospike, it's again, I see the bin, which is 1, and the count is ultimately showing how many times a specific number occurred for each value in the one bin or column, if you will. So it's basically kind of a histogram. So again, just in summary, we were able to push data from a Python client into Aerospike, use the change notification, pushing data to Kafka. And from Kafka, we were able to push data into Spark streaming API. And from the Spark streaming API, we made a very simple calculation, not calculation, it's kind of like a summary account. And then that data is being pushed back into a new data set in Aerospike. So that was a demo. Again, it was a very basic demo, but of course, in your environment, it can be way much more complicated. And we have this scalability to support it. Finally, again, thanks for visiting Aerospike. If you would like to learn more about the database itself, there's an open a community edition of the Aerospike database you can download, and you can actually start working on it. As I mentioned, we have a number of Connect products for Aerospike to connect to various data sources in the enterprise. We have a specific page for Connect for Kafka. This is the URL. Please go ahead and review that. There's more technical information and more specs, if you will. And if you have some specific questions about the technology, please send an email to Kiran. Kiran did the presentation yesterday and today, and he also did the demo before I did the demo. So again, if you have any specific questions about the technology, please send him an email. With that, I would like to conclude this session, and let me go to the Q&A portion of the summit. Thank you.